Hello everyone, today we are trying to work with the right angle triangle to find the trigonometric ratios. So over here we have a right angle triangle and it has an angle theta. So the symbol over here is called theta. It has little curves. It looks like a zero, but it's not zero. Okay, so it's zero. It's a Greek letter called theta. And we already know that whenever it's right triangle, we use the two things. One is Pythagorean theorem if we need to find the sides and we have a missing side. And we also use SOHCAHTOA, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We also need to find other three trigonometric ratios, which is the reciprocal of these. Those are called cosecant, secant, and the last one is cotangent. Okay, these are going to be opposite of this one, the reciprocal. So for this one, we have sine, right? It's opposite and hypotenuse. For cosecant, we're gonna have hypotenuse and opposite. This one is cosine and it has adjacent and hypotenuse, whereas secant is going to have hypotenuse over adjacent. This is tangent, we say tan, which is opposite over adjacent, and we have cotangent, which is adjacent over opposite. Okay, so if we know this SOHCAHTOA, sine, cosine, and tangent, okay, we know the reciprocal of them are going to be cosecant, secant, and cotangent. So we're going to know all six trigonometric ratios. Now, if I look at this triangle, let's name the sides. We know this is a 90-degree angle. We know the opposite of that 90-degree angle, this 14, is the hypotenuse. It's always opposite of 90 degrees. Okay, that's called hypotenuse. We also know this angle theta. If you go across or opposite of that angle theta, that side is called opposite. So this length is opposite for that angle. Okay, and this 7, so this 7 units is next to that angle theta, so we call this adjacent. Remember, adjacent means next to. So 7 is next to theta. So we have three things: adjacent, opposite, and hypotenuse. And we're going to use this in each of the trigonometric ratios to find them. Now let's go ahead and find the sine first. So we know sine is sine of theta angle is opposite over hypotenuse. Now if I look in my triangle here, I have my opposite, but it does not give me what length is my opposite. Okay, my hypotenuse over here is 15. So if I want to go ahead and solve this, I don't know what my opposite is. I just know my hypotenuse, and my hypotenuse is 14. Okay, let's do the cosine now. Cosine is adjacent over hypotenuse. My adjacent is 7 and my hypotenuse is 14. So I have both values here. If I reduce it, 7 times 1 is 7, 7 times 2 is 14. So my cosine theta actually has the value of half. Let's find the tangent. Tangent is opposite over adjacent, and again my opposite is not given, okay, so it's missing, and then adjacent is 7. Okay, since it's missing, we need to go and find it. So the only way to find the third side, if two sides are given to me, is a Pythagorean theorem. Remember, in right triangle we use a square plus b square equals c square, so we are going to use that. Remember, c stands for hypotenuse, so I will have to replace that That's the longest side. So 14 square. And my A can be my adjacent, which is 7 square. And the B is my opposite, which we need to find. That's missing. That's what in our case right here. Let's do the math here. 7 times 7 is 49. Plus B square equal 14 times 14 is 196. Let's solve for B. Okay, so let's subtract opposite order of operation. Minus 49 from both sides. I'll be left with B square equal 16 minus 9 is 7. 8 minus 4 is 4. And 147. We have B square. The opposite of square is square root. So we're going to square root both sides. So I have square root of 147. So let's factor that out. What is the number that goes into 147? Does 2 goes into 147? It's a odd numbers, so 2 only goes by odd even numbers. So let's go by 3. 3, how many times goes in 14? 4 times. There will be leftover of 2, so that's 27. And 3 times 9 is 27. So 49 times goes into 147. We also know 7 times 7 is 49. So I have a pair of 7. So my B is going to be equal to 7. And then we do not have a pair for this guy. So that is gonna go inside the root 3. Okay. So my opposite was 7 root 3. So in this case, my B is O, right? So my opposite is 7 root 3. Okay, so let's go back. Now we found that this opposite was 7 root 3. I'm going to plug in my SOHCAHTOA. So instead of what? I'm going to put 7 root 3, since I found out I'm missing side, divided by 14. 7 times 1 is 7. 7 times 2 is 14. So this is equal to root 3 over 2. Again, for tangent, I'm going to replace that what with 7 root 3 and divide it by 7. 7 goes in 7 one time. 1 times root 3 is root 3. So I found my 3 trigonometric ratios. I also told you at the beginning that these are the opposite of these 3 trigonometric ratios. So we are going to find the next 3 as well. So we're just going to reverse whatever we found over here. So cosecant of theta is going to be whatever your opposite and hypotenuse, it's just going to be flipped. So instead of root 3 over 2, it's going to be 2 over root 3. Okay. My secant is also going to get flipped. My secant is going to be opposite of the cosine. So instead of 1 over 2, it's going to flip, which is 2 over 1. And my tangent is going to be also, instead of root 3, it is going to be 1 over root 3. Okay. Now the other thing that you need to be careful about is you cannot have root on the bottom. Okay, so we need to simplify it. So to simplify it, all I'm going to do is take my bottom and then multiply by the same value. So if I have root 3, I'm going to multiply it on the top and the bottom, which is going to give me 2 root 3 on the top and root 9 on the bottom, which is same as 3. So now I don't have root on the bottom. We also know 2 over 1 is equal to 2, right? Over here we have root, we have to rationalize it. So again, we're going to multiply by whatever value is on the bottom, on the top, as well as on the bottom. Again, root 3 times 1 is root 3, and root 3 times root 3 is 3. So here goes my 6 trigonometric identity: sine theta, cosine theta, tangent theta, cosecant, secant, and tangent.
Like, subscribe and follow at Supermath Guru, K4C. And do not forget to practice every day.